$5.99, Conways 2H. Let's get into it. In Conways constants, we've added a whole bunch of constants here, 1 through 9, that have these weird-ass hex numbers. They actually represent 3x3 grids of bits that are classifiers that are going to help us know which state to transition to when we're looking at a certain tile and its neighbors. So right here, these are the actual decimal values of these, just so that when we're debugging, we know what these numbers mean when we see them. Okay, let's go down a little bit further. So in the Conways data section, we have a little key here to understand what these ones and zeros are. And then we are drawing these little diagrams. So this diagram here says that we have a tile in the center. This is where you are, and you exist, and there's nothing around you. And then what we're going to do is we're going to subtract. We're going to minus, right? So this is what the classifier has picked up on, and this is what we should do. That's what this means. So this is pattern 1, right? This is pattern 1 right here. Then we have all these other patterns, right? This is pattern 2, and then we have pattern 3, we have pattern 4, and 5, and 6, and there's 7, and there's 8, and there's 9. And don't worry about these exact rules. Some of them are completely nonsensical and don't make sense, but I don't care as long as we get a symmetrical output. Here is a lookup table that takes the pattern index and converts it to one of those arrays that we just listed. So we have all 9 arrays in here. And then we also have another lookup table that takes the pattern index and converts it to the binary equivalent. So these are all the same names as these names, but they start with a C underscore for const because these are the binary values, and these are the analogous arrays that represent those binary lookup tables. Okay, right here, we're gonna check our values. We're gonna cross-check our values, right? So what we're doing is we're looping through every single pattern index, and we're going to convert the array into a binary value and make sure that the binary value that we created matches the binary value that's stored, right? And if it doesn't, we're going to throw an error here. Okay, let's go down to the next section. So here is what we did previously, and then here is some footnotes and stuff, and some diagrams and stuff, right? I don't have time to explain all of this. Here's what we did previously. Here's what we did in this video. If you want a good explanation of what I'm up to, you're really going to have to go here, because I just don't have time on this playlist, because it's a very fast playlist. Like and subscribe, send money.